Today in this video I am going to explain the method to solve simultaneous equations by matrix method. First I will tell general algorithm to solve, and then after I will explain the method taking a suitable example. So let's start. Suppose a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3 are the three simultaneous equations to be solved. So first step, first we write the equations in matrix form as follows. So first we write a matrix of the coefficients of x, y, z, that is matrix A1, B1, C1, A2, B2, C2, A3, B3, C3 matrix closed, then multiplied by a column matrix of variable x, y, z is equal to a column matrix of constant terms d1, d2, d3. This is the way to represent a system of simultaneous equations in matrix form. Now step 2. In step 2, we assume this matrix as A, this matrix as X, and this matrix as B. So we name it equation number 1 and this as equation number 2. Then comparing these two equations, it's clear that A is equal to matrix A1, B1, C1, A2, B2, C2, A3, B3, C3, and X is the column matrix X, Y, Z, and B is the column matrix D1, D2, D3. Then in the next step, we multiply equation number 2 by A inverse. Multiplying equation 2 by A inverse leftwise. We get A inverse into AX is equal to A inverse into B. We have multiplied both the sides of this equation by A inverse, so we get A inverse AX and here A inverse into B. Now as you know by the property, A inverse A is always equal to identity matrix, so we may replace A inverse A by I, that is Ix is equal to A inverse B. And other property, then if we multiply any square matrix, any matrix by identity matrix, the answer is the matrix itself. So by this property, if we multiply I and x, we get x as a result. So we get x is equal to A inverse B. Make it equation number 3. Now here we find A inverse with the help of this matrix by cofactor method or by elementary row transformation method, whatever you like. So find A inverse and then substitute the value of A inverse and the matrix B over here, and after that multiply them both. So you will get 2 column matrix on both sides. Equating them, we may find the values of x, y and z. So this is general algorithm of matrix method of solving simultaneous equations. Now let's take an example. So we have taken these 3 simultaneous equations. X plus 2y plus 3z is equal to 14, 3x plus y plus 2z is equal to 11, 2x plus 3y plus z is equal to 11. And now we have to solve it by matrix method. So first we write them in matrix form. The first matrix is of the coefficients of x, y, z, that is 1, 2, 3, 3, 1, 2, 2, 3, 1, and the second matrix is the column matrix of variables x, y, z, and on the right hand side the column matrix of the constant terms, that is 14, 1, 11, 11. Now name it 1, and now let this matrix as A, this matrix as x, and this matrix as B. So we have Ax is equal to B, that is second. So now we have matrix A is the matrix 1, 2, 3, 3, 1, 2, 2, 3, 1, and X matrix as the column matrix of x, y, z, and B matrix as the column matrix of constant terms 14, 11, 11. Now here I would like to clarify one more thing, that before proceeding from this step, we must find the determinant of A first, because if the determinant is not equal to 0, then only we may use or we may solve these simultaneous equations. Otherwise we have to check adjoint of A into B. So here's the case first. If determinant of A is not equal to 0, then only the equations are consistent with a unique solution. And the case second, if determinant A is equal to 0, then adjoint of A into B must be found, and if it is also a null matrix, then the equations are consistent with infinite solutions. Infinite solutions. So the second case I will discuss later on. First we have to study the first case. So here determinant A must be found first. So determinant of 1, 2, 3, 3, 1, 2, 2, 3, 1, and that is equal to 1 bracket, this column, this row vanish, 1 ones are 1, 3 twos are 6, minus 6, then minus second element 2 bracket, this column, this row vanish, these 4 elements are left, cross multiplication, 3 ones are 3, 2 twos are 4, minus 4, and plus 3 bracket, this column, this row vanish, cross multiplication, 3 3s are 9, minus 1 2s are 2. So we get minus 5 plus 2 plus 21. So we have 23 minus 5, which is equal to 18. So as you see, determinant A is not equal to 0. So name it equation number 3. And because A determinant A is not equal to 0, so the given system of equations are consistent with unique solution. Now we may proceed. So first, as I told in the general algorithm, first we have to find inverse of this matrix, that is A matrix. We have to find first inverse of the matrix A. So let's proceed. For that purpose, first we have to find the cofactor. If we want to find A inverse by direct method or cofactor method, so first we have to find the cofactors of A. So cofactor of A, the cofactor of 1, this column, this row vanish, 1 ones are 1, minus 3 twos are 6, then minus bracket, this column, this row vanish, 3 ones are 3, 2 twos are 4, then plus this column, this row vanish, 3 threes are 9, minus 2 ones are 2, then minus this column, this row vanish, cross multiplication, 2 ones are 2, 3 threes are 9, minus 9, then plus this column, this row vanish, 1 ones are 1, minus 2 threes are 6, and next minus this column, this row vanish, 1 threes are 3, minus 2 twos are 4, then positive for this row and this column vanish, cross multiplication, 2 twos are 4, minus 3 ones are 3, then minus bracket for this column, this row vanish, these 4 elements are left, cross multiplication, 1 twos are 2, minus 3 threes are 9, and then positive cofactor of this element, this column, this row vanish, 1 ones are 1, minus 3 twos are 6. And here you see I have not explained the way to find the cofactors of A because I have created a dedicated video for cofactors and minors. So there you can watch and understand the method to find cofactors of A, cofactor of matrix. Now just simplifying, we have cofactors of A are 1 minus 6 minus 5, 3 minus 4 minus 1 minus minus plus 1, so plus 1, 9 minus 7, 9 minus 2 7, and here 2 minus 9 minus 7, so minus minus plus 7, here 1 minus 6 minus 5, and here 3 minus 4 minus 1, and minus minus becomes plus, plus 1, 4 minus 3 plus 1, and 2 minus 9 minus 7, and minus into minus becomes plus 7, and here 1 minus 6 minus 5. So in this way we have found the cofactors of A. Now cofactor matrix is the matrix of these cofactors, and the transpose of this matrix is said to be adjoint of A. So we find adjoint of A taking transpose of this matrix. So in transpose, as you know, we interchange all the rows and columns. So first column becomes first row. So here first column is minus 5, 7, 1. So we make it first row for minus 5, 7, 1. Second column becomes second row. So we have 1, minus 5 and 1. Minus 5 and 7, sorry. 1 minus 5, 7, 1 minus 5, 7. Now the third column becomes third row, so 7, 1 minus 5. So here we get adjoint of A. Now as you know, A inverse is equal to 1 upon determinant A into adjoint of A. Substituting the value of determinant A and adjoint of A, we find inverse of A here. So substituting here, as you know, from equation number 3 we have found determinant A in the beginning. So determinant A is equal to 18. So substituting here 18, and adjoint of A we have found in the previous step. So it becomes minus 5, 7, 1, 1, minus 5, 7, 7, 1, minus 5. Now, as you know, by scalar multiplication of a matrix, each and every element of the matrix is multiplied with. So we may multiply it here or later on after substituting the value of A inverse in equation number, sorry, we have not created that equation right now, so we better name it equation number 4. Now in the next step, as I have explained in the general method, we use multiplication. We multiply equation number 2 by A inverse leftwise or rightwise. So multiplying equation 2 by A inverse, we get A inverse. Here we have A inverse AX. So A inverse AX is equal to, on the right hand side we had B, so we have A inverse B. So leftwise we have multiplied equation number 2 by A inverse. So as a result, A inverse into A becomes I by the property. So we have I into X is equal to A inverse B, and I into X becomes X by the property again. We have X is equal to A inverse B. Now substituting the value of X, A inverse and B in this equation, we have X is the column matrix of X, Y, Z. And A inverse is 1 upon 18 and this matrix, so write it down as it is, 1 upon 18 minus 5, 7, 1, 1, minus 5, 7, 7, 1, minus 5, and multiplied by B. And what is B? In the beginning we have written this. B is the column matrix of the constant terms. So write down B over here, 14, 11, 11, right? So we have this. Now just we have to multiply these two matrices first, 1 upon 18 as it is, and multiply these two matrices. So first row is will multiply the first column, only one column it has. So 14 into minus 5 is minus 70. Minus 5 into 14 minus 70, and plus 7 into plus 11 plus 77. And here 1 into 11, that is 11. Now second row and this column, 1 into 14, 14, minus 5 into 11, minus 55, and 7 into 11 plus 77. Now next, third row will multiply the column. Now 17 into 14. 7 14s are 98. Plus 1 into 11, 11. And minus 5 into 11, minus 55. So we have 1 upon 18, and in the column matrix we have 77 and 11, both are positive, should be added. So we have 88 minus 70, and here these two terms are positive, 14 and 17. So adding them up, 7, 4, 11, 1 carry over number 8 and 1, 9, 91 minus 55. And here these two terms are positive, so adding them up we have 1 and 8 and 1, 9, and 1 in plus 9, 10, 109 minus 55. So at last we have 1 upon 18, and column matrix 88 minus 70, 18, and 91 minus 55, 5 from 11, 6, and 5 from 8, 3, 36, 109 minus 55, 5 from 9, 4, 5 from 10, 5. So by scalar multiplication, each and every element of the matrix will be multiplied. So 18 will divide all these three terms. 18 divided by 18 we have 1, 36 divided by 18 we have 2, 54 divided by 18 we have 3. So comparing both the sides, here on the left hand side we have a column matrix XYZ, on the right hand side we find the column matrix 1, 2, 3. So comparing them we get x is equal to 1, y is equal to 2, z is equal to 3, and this is the required solution of the simultaneous equations. So this is a way to find the solution of simultaneous equations, and the same algorithm may be applied on 2 by 2, and means if a system has only two simultaneous equations of two variables, or 4 by 4, that, or 5 by 5, of any kind of system of simultaneous equations, same algorithm should be applied.